Hey, Miss Marion here. We are going to go ahead and we're starting Unit 4, and we are looking at Lesson 1. And so make sure you have a workbook, and we'll start going up from there. All right, turn to page 4, and let's go ahead and talk about this as far as we're going to evaluate this expression, and then we're going to have x equals 3. So go ahead and pause and go through that, and then come back to me. All right, so where x is, we're going to put in 3. So we're going to say 4, 2 times 3 plus 3, and then plus 4, all over 8. So let's go ahead and go through this. So we're going to have 2 times 3 is 6. So we have 4, 6 plus 3, plus 4, still all over 8. We have 4, 6 plus 3 is 9. Plus 4, all over 8. And then remember that if we have parentheses and a number sitting on the outside, that's multiplication. So we're going to go ahead and we're going to multiply 4 times 9. 4 times 9 is 36. And then plus 4, all over 8. 36 plus 4 is 40, all over 8. And then 40 divided by 8 is 5. So we're going to use this concept today about understanding about equations and kind of like where they come from as far as solving something kind of in this format here. And so make sure you understand this and make sure that you read it down on page 4. All right, so our target and learning standards, these are questions that we're going to kind of answer. How does connecting the operations in an inequality to an action in a story help me develop and justify my solution process for solving equations? And then how does the structure in an equation give me clues about how it is solved? And so those are the things that we want to do. We want to look at different stuff. We want to understand how it's going to be solved. And then we're also dealing with a story problem today. So don't worry, we'll be fine, but we're dealing with a story problem. So we're going to first read this story without any numbers on it, just to make sure we understand the concept, and then we'll read it with numbers in it. So that's why there's some blanks in here. So Elvira, the cafeteria manager, had just received a shipment of new trays with the school logo prominently displayed in the middle of each tray. After unloading blank number of cartons of trays in the pizza line, she realizes the students are arriving for lunch and she will have to wait until lunch is over before unloading the remaining cartons. The new trays are very popular, and in just a couple of minutes, blank number of students have passed through the pizza line and are showing off the school logo on the trays. At this time, Elvira decides to divide the remaining trays in the pizza line and into blank equal groups so she can also place some in the salad line and the sandwich line, hoping to attract students to the other lines. After doing so, she realizes that each of the blank serving lines only have blank of the new trays. Okay, so what are we talking about? Elvira, she's a cafeteria manager. She's dealing with trays, right? And she's trying to go ahead and put them through different lines. And let's go ahead and let's read this again, actually with the numbers on it. All right, so Elvira, the cafeteria manager, has just received a shipment of new trays with the school logo prominently displayed in the middle of each tray. After unloading 4 cartons of trays in the pizza line, she realizes the students are arriving for lunch and she will have to wait until lunch is over before unloading the remaining cartons. The new trays are very popular, and in just a couple of minutes, 24 students have passed through the pizza line and are showing off the school logo on the trays. At this time, Elvira decides to divide the remaining trays in the pizza line into 3 equal groups, so she can also place some in the salad line and in the sandwich line, hoping to attract students to the other lines. After doing so, she realizes that each of the 3 serving lines only have 12 new trays. That's not many trays for each line. I wonder how many trays there were in each of the cartons I unloaded. Okay, so think about it. Okay, what were we trying to figure out? All right, so we're trying to figure out how many are each unloaded. So go ahead and answer that question and then come back to me. All right, so she has 12 trays in 3 lines. And then there must have been 36 trays before Elvira divided them up. So that's 36 trays. Right? And then since 24 students removed trays after lunch period started, there must have been 36 plus the 24, and that will give us 60 trays. That were unloaded. So since 60 trays came from 4 cartons, okay, so 60 trays in 4 cartons. So how many are in each carton? Well, okay, if we do 60 divided by 4, then there should be 15 trays in each carton. Awesome. So let's go ahead and let's look in further as far as this story itself. So Elvira is interested in collecting data about how many students use each table during lunch. She has recorded some data on sticky notes to analyze later. Here are the notes she has recorded. Does it matter which order the notes were recorded in? Determine how many students were originally sitting at the front table based on the sequence itself. So let's read these. The first one is, some students are sitting at the front table. I got distracted by the incident in the back of the lunchroom and forgot to record how many students. Number 2, each of the students at the front table has been joined by a friend, doubling the number of students at the table. The next one is 4 more students have just taken seats with the students at the front table. Fourth, the students at the front table separate into 3 equal-sized groups, and then 2 groups left, leaving only 1/3 of the students at the table. And then the last one is, as the lunch period ends, there are still 12 students seated at the front table. And what we're going to do is we're going to figure out, does it matter which order the notes were recorded in? And then we're also going to determine how many students were originally sitting at the front table itself. So in math, we know that what are we trying to figure out? How many students are originally sitting at the front table? And in math, we don't know things. When we don't know things, we're going to define a variable. So we always have to go ahead and we have to define a variable. And I'm going to say, let x equal number of students sitting at the front table. Okay. All right. So we're going to be using this. And what I want to do, I think working backwards is actually like to figure out like what do we write down as far as having to like solve this itself. So the last one, it says, as lunch period ends, there are 12 students seated. So I'm going to draw that out. So at the end, so if we have a table, we have 12 students. Okay. And then it says, then let's go back to the other one. The students at the front table separated into 3 equal-sized groups, and then only two groups left, leaving 1/3 of the students at the table. Okay, so this first part is kind of like what is left over is 12, and then we still have that table, and we okay, and what happened? Well, they went into 3 groups of equal parts, and then eventually 2 of them 2 of them left, right? So now how many students do we have? Well, we have 36, right? And then if we go back again, it says 4 more students have just taken seats with the student at the front table. So to go up, because we're going backwards, right? To go up, that means we need to take 4 off. So if we have our table, right? And we're going to take off 4 of them, right? Then what do we have left over? Well, so we're taking off 4 from the 36. We're going to have 32. Okay. And then each of the students at the front table has been joined by a friend, doubling the number of students. So the 32 was doubling. So what are we doing now? Oh, okay. So if we have it where it's doubling, then we have it where this end result here is going to be 16. So pretty much we're taking these and like putting them in like groups of 2, I guess, either way. And then we end up having the 16 itself. So this is just a way of actually looking at it, seeing what's going on, right? And the end result was 12, but we have it where we started technically with the 16 itself. So I guess I shouldn't have x equals 12. I guess the end result down here is 12. Okay, so if we want to go ahead and let's actually write an equation about the sticky notes, right? So we started with 12. So we have it where eventually we solved it. X is going to equal 12. Okay. And then let's go ahead and let's kind of figure out. So we went with 12, and this says at the front of the table, separated into 3 equal size groups, and then 2 groups left, leaving only 1/3 of the students at the table. Okay. So we have where we have 2 groups, right? There was a third left over of that, but then also we had this where we had 4 kind of went up there. So we have it, so we had the 3 groups. So there's 3 groups in total. 4 more students have to take the seats, and then each student was adding a friend. So if we kind of actually write this together, our equation actually is like 2x plus 4. All of that, it's divided by 3, and then it's going to equal the 12. So let's put that together. So all this equals 12. Oops, sorry. 12. So here is the equation that actually goes along with kind of what's going on, right? So how did we get the 2x? Because we went from 36 to 32. So that's kind of like the 2x plus 4. And then we went from 32 to, because it's doubled, right? In a way. So we started with how many students are at the beginning. Then each of them doubled, right? So that's where we get the 2x. 4 more students came and sat there, so that's why we have 2x plus 4. And then we have it where it was they went into 3 equal groups. 2 of the groups left, right? And then it left the 12 at the end. So notice how we were able to go ahead and write an equation for these sticky notes to kind of figure out what's going on, to go ahead and solve Elvira's issue with how many students were at the beginning or sitting at the front desk at the beginning, which was 16. So notice how we have these orders, and then we get this piece of information. Well, what I did is I took the same sticky notes, because Elvira knew what the beginning sticky note was, and she knew what the end sticky note was. She didn't know the order of the 3 in the middle. And so I went ahead and I flipped these two sticky notes because I want to kind of see, does the order of the sticky notes matter? That's our goal kind of thing. So again, let's kind of work backwards again, right? So we're going to end up with the 12, right? And then the students at the front of the table separated into 3 equal groups. So I ended up with 12. So that means I need 3 groups of 12. Right? And here are my 3 equal groups. Right? So if I have 3 equal groups, I started with 12, 3 equal groups. How many are going to be left over? Here's the 36. And then the next sticky note, this is different from what before. It says each of the students at the front table has been joined by a friend, doubling the number of students. Each one that has been done, they have it joined with a friend, doubling each number of students. So we're going to have like 2 times something, right? Okay. So if I have it where, joined, actually I wrote that in the wrong area. Let's write that a little bit down further. So we're going to have 2, well, I'll write in black, 2 multiplied by something. So I'm going to take that 36 in groups of 2. So if I took 36 and I kind of do it backwards, that means I'm going to have 18 left there. Because of the 36, we're kind of doing groups of 2. How many groups of 2 do we have is 18. Okay. And then it says 4 more students have just taken the seats at the front desk. So we don't know how many are at the front, but we're going to add 4. So we have like x plus 4 already. And then we started with the x. And we forgot to define our variable at first. We're going to say let x equal the number of students at the front desk. Sorry. Okay. All right, so this is kind of the order, right? But let's go ahead and let's put it together and let's make an equation. So we had the x, we added the 4, and then we put the 2 with it. So we had like 2 double, so we had 2 doubling the x plus 4, and then a third of them, right? And then we're left with the 12, right? Okay, so this is a different equation that we just barely did. And the question is, like, how many were at the beginning there? So notice how we had we went from the 2, got into the 18. So we added 4 here. That means we need to pretty much subtract off 4. So then how many were at the front desk? That's 14. Okay. So if we took this equation, let's take this equation and let's go ahead. Let's just solve it. We know how to solve these, right? So let's go ahead. Let's get rid of that 3, right? It's dividing. We're going to do opposites. We're going to multiply by 3, right? And then 3 divided by 3 leaves that 2. And then we have 12 times 3. Okay, that's 36. So now we want to go ahead and we want to get rid of the 2. So we're doing opposites, right? So opposite. And this is multiplying because it's sitting on the outside. And we can divide by 2. 2 divided by 2 leaves 1. Leaves x plus 4. Right? 36 divided by 2. That's the 18. And then 18 plus 4, right? We have to do opposites. Minus 4. And then we have x equals 14. So 2 different ways of actually solving this. One is algebraically. And the other one is actually just working with the sticky notes and kind of working backwards with what the sticky note is actually saying. But notice how each of the sticky notes themselves is a way, so we go from 12 to 36. We ended up with, like, we had the 3 groups and 2 left, right? So then we have the 12, we go to the 36. Here's the 36, right? So then we need to get rid of the 2. So we have 36, and they were in groups of 2 because every student had a friend. Well, we took it and we divided it by 2. Here's our 18. And then it said we had 4 more students, and we're going backwards. So that means we need to get rid of 4, and it leaves the 14 itself. So one is algebraically, the other one's just kind of logically thinking with those sticky notes themselves. Now the question is, does it matter what order the sticky notes are in? Well, let's look at that. So here are the different ways of the sticky notes. We actually did this top one, where our x was equal to 16. And then we did the bottom one, where our x equals 14. So does it matter which order we actually set things up? Absolutely. And then in the middle one, notice how the middle one is like we swapped the outer 2 and left the middle kind of thing. And then, so we've done the top and we've done the bottom. But now we can also look at the middle one. And there's ways of setting this one up. We can go through that if we want to. But I want to really focus on, there's different, if we set them up differently, we're going to have different answers. So let's go ahead and let's figure that out. So on page 5 to 6, we solved the first one, right? This was x equals 16. We solved the last one. This is x equals 14. And then let's solve this middle one, which is the third way. So go ahead and solve this with the information that you know. Go ahead and solve it and see if it has the answers of the other 2. And then come back to me. All right, so we're solving it, right? So I see that there's a multiply 2. We're going to do opposites. I'm going to divide by 2 on both sides. So then I have x divided by 3 plus 4. 12 divided by 2 is 6. I see a plus 4. We're doing opposites. So we're going to do minus 4. We have minus 4 on both sides. So then we have the 4's go away, right? So we have x divided by 3 equals 6 minus 4 is 2. And then we have it divided by 3. So then I'm going to go ahead and multiply by 3. 3 divided by 3 leaves x. And then notice how this x equals 6. So this is a total different answer than even the other 2. So again, as far as Elvira kind of stuff, we really haven't answered her question. Well, we did answer her question. Does it matter what order these actually go in? Absolutely. Unfortunately, we don't know what order she was in. But we're being able to kind of show, hey, there is something that goes on with this, and there is, there's stuff that happened with it. So here is our takeaways for today. On page 6 to 7, we have our different takeaways. Today we used operations of arithmetic to represent actions in a story content. We used grouping symbols and order of operations to write an equation to model a story content, and then used the story content to help us justify a process of solving the equation. In general, we have learned that when solving a linear equation, we undo operations in the equation by, and then and it's called inverse operations. So we did everything by doing the inverse, doing the opposite. So make sure you write that down. And then the order for applying inverse operations is the reverse order of what is used when evaluating the expression for a specific value of the variable. So we learned in 8th grade solving equations, actually in 7th grade too, that whatever we see, like if it's multiplying, we're going to do the inverse, which is divide. Or if we see add, then the inverse is subtract. So this actually kind of shows that, yeah, this is kind of like a reason why. Why are we doing this? Well, we started at the end result because that's where we know where to start as far as over irs kind of stuff. And then we worked backwards to go ahead and figure out what the original answer was. And then we can actually do that algebraically also. So also on page 7, some other takeaways that we have, and I'm not expecting you to know these by heart, but we can justify each step in the equation solving process by using properties of equality and properties of operations. So the distributive property, we've used that where we take the A and we multiply it in. This is the addition property of equality. So if I do A plus B, if I add C to both sides, I still have that balance. So it's kind of like last year we had those balance operation tables, or the T-chart kind of stuff. Whatever we do to one, we have to do the other. Subtraction property of inequality. Again, we have A and B. I can subtract off C from both sides. It still makes that balance tree. And then multiplication property of quality. So I can go ahead and multiply both sides. Still has, makes that tree still balanced. And then division property of inequality is where we can divide by stuff on both sides. So this is the mathematical way of actually showing all these different properties. But make sure you have this and make sure you understand like what it actually is. Because we're going to be talking about more about this through this whole entire unit as far as the different properties that we use in math, because of, this is our way of actually showing, and this is a way of proving what we actually have. All right, so let's go ahead and let's talk about retrieval. So this is going to help us with our homework. We are on page 8. And so we want to graph the situation, and then we want to figure out if 1, 3 is on the point. So let's go ahead and graph this. We were talking about graphing the other day. So what is our slope? Yep, sorry. So our slope is -2. We're going to put it in fraction form, -2/1, because we need that slope triangle. What is our y-intercept, or where do we start, where do we begin, is 5, right? And let's go ahead and let's draw our x-axis. Let's draw our x and y axes, right? And so we have our beginning is 5. So we're going to go up to 5. 1, 2, 3, 4, 5. Positive 5 on the y-axis because it's the y-intercept. And then our slope is -2. So we're going to do a slope triangle of negatives. So that's going down the hill. Right? And then this would be our line. So the final part of this is we want to figure out if 1, 3 is on the line. So over 1, up 3. 1, 2, 3. This point right here is 1, 3. Is this on the line? Yes. So our answer is yes. That point is on the line. We can also put it where we can put x and y into the equation and see if both sides equal. That's also another way of actually doing this, but I like to see the graph because it shows it visually. All right, number 2, this is also on page 8. It says indicate where the given value is a solution to the equation. Show your work to justify your response. So honestly, I'm going to try this a different way. We can solve this, right? We can solve it as far as the steps and different things. I'm going to show this a different way. I know the n is 5, so I'm going to go ahead and I'm just going to say -5 times 5 plus 13. So I actually just put this in for the 5. So -5 times 5 is -25. And then we have plus 13. So let's go ahead and let's grab our calculators. So our final answer here is -12. Now we want to ask, so they say our answer should be -9. Do both of these equal? They don't. So our answer is no. N equals 5 is not an answer for what we're actually looking in. All right, so let's do the same thing for number 3. So B equals -7. So I'm going to have it, let's change our color. So we're going to have 2, -7 plus 5 equals 3. negative 7 minus 2 plus 23. So we're going to find out if both sides equal. So negative 7 plus 5, because we're going to do the parentheses first, right? So we have 2 times negative 2. 2 times negative 2 is negative 4. Okay, that's the one side. Let's do the others. We have 3 on the outside. Negative 7 minus 2. That's negative 9. And then plus 23. And then let's go ahead and let's do, okay, we need to do what is 3 times negative 9. So 3 times negative 5 is negative 27. And then we're going to add 23 to it. Negative 27 plus 3 is negative 4. Do both sides equal? Yes. So b equals 7 is an answer to number 3 question. So our answer here is yes. So notice how we can put our letters, our numbers in for the letters, and we can see if both sides equal. And then if both sides equal is, then yeah, that's an answer. Awesome. So we're going to go ahead and do check for understanding. Sorry, that didn't come through really quickly, better. But it's Unit 4, Lesson 1, and we're doing that. And make sure everything goes into Canvas. Have a good day. Thanks. Bye.